Hello scholars, welcome! Mr. Hinkle, let's talk about fluvial processes. Fluvial, flowing water. Fluvial geomorphology, river science. Process, how things work. So we will identify and analyze significant fluvial processes in river systems. First, we want to define. Processes dictate how a river behaves. They create fluvial landforms. I mentioned in fluvial landforms lecture, it's a bit of a chicken and an egg, which came first, the process or the form, and they essentially work together, kind of like the chicken and the egg. They both are. Fluvial processes include velocity, slope and gradient, erosion, transportation, deposition, equilibrium, and base level. Not exhaustive, but exemplary. Let's get into it. So velocity is how fast the water is moving. How fast is the water moving in this channel? Well, we can measure it as a rate, a distance over time, usually in meters per second. Let's see, so processes. Let's utilize this board. Velocity is a rate, which equals a distance over time. In metric, it's usually a meter over a second, and in standard, it is a foot per second. So, that's awesome. Stream velocity is going to be higher in the mountains where the gradients are steeper. It's going to be fastest in the middle of the channel and then on a bend on the outside. In fact, this is called the Thalweg. Thalweg, it's a German term where it was first discovered and identified by German fluvial geomorphologists. And we can say there's a portion of the river where it moves faster and slower. On the outside of a bend, in the very center when it is straight. And we can use the Thalweg in order to understand the characteristics of a river. So Thalweg is important for understanding how rivers flow in these river systems. Water is a powerful agent of erosion, but once sediments are eroded, they are then transported. So I think of rivers as conveyor belts of water and sediment. It's what they do. What do rivers do? They move water, they move sediment, and along the way they provide habitat for a variety of different species. They also create small bed forms from the sediment that's on the bottom of the stream bed. So fluvial processes leading to fluvial landforms. Awesome. When rivers slow down, they deposit. They drop their sediments. Smaller sediments are dropped as the slope becomes less steep. Again, these fluvial processes are creating fluvial forms. Here we have turbid water, a delta here at the mouth of this river system. The longitudinal profile. Steep in the headwaters, very shallow at the mouth, giving us zones of erosion, transportation, deposition. Well, how steep a river is known as the stream gradient. It is measured by the drop in elevation per unit of horizontal distance. So this is a basic rise over run type problem, giving us slope, usually expressed as meters per kilometer or feet per mile. The gradient is really important for dictating what fluvial processes will occur and for giving us our various channel types and the various fluvial landforms. And hopefully, as you are making your way through these series of lectures, you're starting to get an understanding that channels look a certain way and they have characteristics. Certain processes are creating the shape and the forms that we see, and those forms are going to allow these processes to occur within them. It's awesome. Stream equilibrium. So this is a concept. And rivers are going to tend towards a steady state equilibrium, where the amount of water and the amount of sediment is pushed through. But it's much more complex than this. So what ends up happening is you have some floods, you have landslides, you have various inputs, you have a dynamic equilibrium that oscillates around this steady state. The tendency for a river to adjust towards the ability to push through, to transport the amount of water and sediment provided. I love this concept because this is balance. This is balance. This is a river trying to balance the external factors that are happening to it, but adjusting all along the way. And when there are disturbances, it's still maintaining that balance. It understands that I may never reach that perfect steady state equilibrium, but my adjustments all along the way tend towards balance. We have a lot to learn from rivers. In fact, I consider rivers to be one of my greatest teachers. If you've ever been to the river, you can sit on its banks and close your eyes, breathe deep, and listen to what the river has to say. They speak wisdom. Part of their wisdom is equilibrium. This is a waterfall. In fluvial geomorphology, we call this a migrating nick point because the river will adjust to these areas of localized base level where erosion cannot proceed below it. The ultimate base level where erosion can't go any further in the entire world is the ocean, because at sea level, there's no more gradient. Rivers aren't carving down. You're not going to get carving down below sea level. So the sea level is the ultimate base level. There can be periodic base levels in the form of lakes or waterfalls that also will adjust the characteristics, or the rivers will adjust in response to these localized base levels. So, fluvial process. Really important in the discussion of fluvial geomorphology. They help to create landforms, and they respond to the features of the landscape that influence them into the subsurface and the surface geology, into the slope and the gradient, and the processes that will adjust are going to be what I've discussed here: velocity, gradient, how much water is flowing, equilibrium, and localized base levels. So thank you so much. We're getting a good idea of fluvial geomorphology. We're getting a great understanding of rivers and river science. Keep up the good work. You're doing great. I'm proud of you, and thank you so much.